Thanks for this nice introduction. I will first start to give you the outline of my presentation, where actually I will start first by defining what we understand around bone development. I will mention also the two key ossification, which is the endochondral ossification and intramembranous ossification, which are key driver actually of height, but also of bone strength. Then we will start to discuss around the gut musculoskeletal axis concept as a new holistic nutritional strategy for the musculoskeletal system. And we will dig particularly much more on the microbiome mechanism of action on the musculoskeletal system. And finally, I will finish by give you new exciting result of efficacy of a symbiotic on the musculoskeletal benefit by showcasing actually the first randomized control trial in toddler that we have performed in Nestlé, and finished by a take-home message. So toddlerhood is a really key period for healthy bone development for both bone length and bone strength, where bone length actually will drive your height, and bone length, which is determined by different criteria like bone geometry, but also bone mineralization, and particularly bone mineral density. And you will see that there is a last determinant of bone strength that I will mention in the next slide. Why actually it is toddlerhood is a critical period? Because you can see that, as discussed yesterday, growth velocity remained quite high in the blue line that you can see here. So what I was saying is I wanted to highlight actually which are the key mechanisms of action which drive bone length and bone strength, and actually it's the endochondral and intramembranous ossification, particularly endochondral ossification, which drive your bone length due to the huge activity of the growth plate, and then more for the intramembranous ossification, the huge activity of modeling and remodeling, which will drive much more your width of your bone. And the novelty that I would like to bring, particularly in early life, is when you talk around bone strength, you need to take into consideration not only bone mass, but also bone quality, which is a key determinant of bone strength. And the novelty that we bring is that actually, since it has been demonstrated yesterday, bone length acquisition is something which is quite linear in terms of acquisition from birth, whereas bone quality that you can see on this graph, which is determined here by tibia bone speed of a sound, is much more a trajectory with a U-shaped curve, where you can see that the curvature point is occurring during 4 months to 6 months, and that you can also appreciate that this bone quality is sensitive to preterm effect. But the things that we particularly observe is that this curvature point period occurs during and is associated with a massive changing of around the microbiome transition, particularly around the key microbial metabolite which is secreted during this period, the short-chain fatty acid that I already mentioned, and that you can see also that there is a shift of different type of bacteria, like bifidobacterium, which are represented in blue, compared to Blossia, which are represented in orange. And what is the beauty of this period is that it's where you start to have your food introduction. And actually, it has been demonstrated that food introduction during this period really changed massively the production and the synthesis of microbial metabolite and different taxa. And based on this observation, actually comes up the new concept of a gut-bone axis, which is demonstrated through two key observations. The first one is that key factor of bone remodeling are regulated by the gut microbiome activity. And the second key point is that nutrition has the ability to influence microbiome diversity and activity. And you can see on this graph, actually, that bone quantity and quality, which is illustrated throughout life with the blue line, is quite well associated with microbiome diversity, which is illustrated here on the red line. And you can appreciate that this is particularly true during early life. actually, the real demonstration in terms of causality of this gut-bone axis have been then demonstrated through preclinical study, and particularly in aging and not in early life, using this ovarectomized model mice which induce osteoporosis, and where they definitively describe a modification of your gut activity, particularly the permeability of your gut, which is increased, but most also in modification of the microbial metabolite that have been described, and not only the short-chain fatty acid. And the beauty of the experiment is that when you perform fecal transplantation of a healthy mouse into an osteoporotic mice, you can see that actually the gut environment is changing. There is a reverse effect with an increase and a decrease of the permeability and a modification of the microbial metabolite which is created, and the impact is that you boost bone formation. So this is nice in terms of causality demonstration, but what are the mechanisms of action in order to explain how the gut can impact the bone and the muscle? Actually, there is mainly 4 different mechanisms of action. The first one is the production of microbial metabolite that I mentioned, and you will see later on that there is not only the short-chain fatty acid which can impact the different tissue. Then you have a modification through the bacteria of the pH, which will impact the mineral absorption, particularly the key building blocks of the bone and muscle, like the calcium and the magnesium. There is also a modification of the secretion of different gut hormones like serotonin, ghrelin, or GLP-1, which is well known to impact the bone and muscle tissue. And lastly, there is a modification of immunity, which is well known to be performed at the level of the endothelial cell of the gut, and particularly the impact of decreasing inflammation. And actually, these 4 different mechanisms of action have been demonstrated to impact the bone cells, and particularly to boost the bone-forming cell, which is called the osteoblast, and to decrease the activity of the bone-resorbing cell, which is called the osteoclast. Whereas at the level of the muscle, it has been demonstrated this the key microbial metabolite has the ability to increase the 3 different outcomes which is key in order to improve muscle function, which is the increase of protein synthesis, increase of glucose uptake, and the activation of mitochondria, which is a key feature in order to provide energy to your muscle. So before to go deeper on the impact of the microbiome on health benefit, you need to understand who are the key drivers of the microbiome. And actually, it's quite simple. There are 2 key drivers of the microbiome. The first one is the bacteria itself, that you can call probiotic when there is already a demonstration that this bacteria has a health benefit. The second key driver is the prebiotic, which is actually the substrate that the probiotic is taken in order to provide and confer the health benefit. What I want to show you here is that there is already a massive list of pre- and probiotic which have been described to confer an impact on bone and muscle. What is really particularly interesting and novel is that actually pre- and probiotic can interact together in order to form a symbiotic with a synergistic effect. So in order to try to illustrate this concept of a symbiotic, I take the example of if you put in a pill a probiotic and a prebiotic. So as a first example, if you put in a pill a probiotic which has a specific health benefit, you will have this specific health benefit, and you add on top a prebiotic which has another health benefit. By taking this pill, you will have 2 health benefits. Whereas when you put in a pill a probiotic and a prebiotic, which has the ability to have a symbiotic effect, you will have for sure the health benefit of the probiotic, the health benefit of the prebiotic. But since the prebiotic will be eaten by the probiotic, you will optimize the health benefit of the probiotic, meaning that you do not have 1 + 1 health benefit equal 2, but 1 + 1 health benefit equal 3. So based on this concept, we decide to dig a bit in the literature about the existing clinical demonstration of a probiotic and prebiotic efficacy. And actually, there is a lot of literature, but you will see that there is a lot of literature mainly in aging, nothing in early life. There is already, and I put an example of meta-analysis, illustrating the efficacy of different probiotics to decrease bone resorption or different probiotics to improve muscle mass. And in order to make a long story short, what we did is we perform a summary of which are the probiotics which has an efficacy on bone, an efficacy on muscle, and an efficacy on the gut. And you can see here as a summary that there is mainly 4 different key probiotics which has the ability to play on these 3 different outcomes, which is L. rhamnosus, L. plantarum, L. subtilis, and L. reuteri. And I will ask you to keep in mind L. reuteri. What we have done is the same exercise, but with prebiotic, and I just will like to showcase 2 different prebiotics which have been really well demonstrated to be efficient to improve the bone and the muscle. The first one is GOS, which is galacto-oligosaccharide, which have been demonstrated particularly in adolescent girls to improve calcium absorption, which is well known to increase bone mineral density. There is the other example of FOS, fructooligosaccharides, which have been demonstrated to increase actually the absorption of magnesium, which is well known to have a key role on muscle function, particularly muscle relaxation. We did the same exercise in order to summarize this prebiotic activity. And here you can see that the finding was inulin, FOS, and GOS are key prebiotic for the bone and muscle. So what we did then, based on this knowledge, and I would like to add that from today, there is really no existing clinical evidence on a symbiotic efficacy on bone and muscle metabolism. So based on this observation, what we did is we check if those different probiotics that we have selected has the genetic capacity to eat the prebiotic. And actually our finding was that L. reuteri and GOS was the perfect combo in order to form a symbiotic. Therefore, we decided to perform a preclinical work in order to confirm and perform a proof of concept of the efficacy of the symbiotic on the production of microbial metabolite first, and then on a health benefit, which was performed on bone and muscle cells. Again, to make a long story short, what we did is we put on a bioreactor mimicking the intestinal system some milk matrix. We had on top L. reuteri alone, GOS alone, or the combo of L. reuteri and GOS alone. In order to mimic the microbiome environment of a toddler, we add feces on top on this bioreactor system, and 48 hours after, we performed some multi-omic analysis. The conclusion was that we increased significantly the total amount of short-chain fatty acid, more than 200%, but more importantly, there was a specific ratio, meaning a signature of microbial metabolite, particularly on the short-chain fatty acid, with a level of acetate of 75%, of propionate 20%, and 5% of butyrate. And when we put this cocktail of short-chain fatty acid and microbial metabolite on bone-forming cell, like the osteoblast, you can see that compared to a simple milk matrix, you have an increase of a key marker of bone formation, which is osteocalcin and particularly alkaline phosphatase activity. Therefore, we decide to move on a clinical demonstration to demonstrate the efficacy of this symbiotic integrated in a new young child formula. And we performed this study in healthy Filipino toddlers aged of 2 to 3 years, where we had 3 different groups. A first group which correspond to the habitual diet, which is in grid, where we leave the children to the local habitual diet. And then 2 other groups, which are really a randomized controlled trial, where we test the efficacy of a young child formula containing the symbiotic, but also different calcium and minerals. And you will find actually the detail of the level of each of these components below the slide. And we use as a control milk minimally fortified cold mix. What we did is we performed some blood and feces collection at baseline, 3 months and 6 months in order to evaluate bone and muscle markers and evaluate the microbiome. And for the muscle outcome, we use an N-grip system that we evaluate at baseline and 6 months. And for the bone quality, we use an ultrasound device which actually give you a criteria which is called the speed of the sound that we evaluate at the tibia, and actually which was our primary endpoint. So as you can see on this slide, we were quite happy to see that the primary outcome was positive, with a significant increase of this TBSOS with a young child formula compared to the control milk, which was explained by an increase of the bone turnover markers after 6 months of intervention. And when we perform an additional analysis, much more a longitudinal analysis, we were quite happy to see that already after 3 months of supplementation with the young child formula, there was a significant higher tibia SOS compared to the control milk. Regarding the muscle investigation, you can see that after 6 months, we have a significant increase of N-grip strength in the young child formula compared to both the control milk and the habitual diet. And what we observe is a significant association between muscle force and the bone quality, so the TBSOS, and particularly this in the experimental group, suggesting that actually muscle force can contribute or participate to, on the explanation of the increase of the TBSOS by the young child formula. Since we have a bit of higher vitamin D in our experimental group, we evaluate the efficacy of a young child formula to restore vitamin D level, and you can see and appreciate that after 6 months we have in the blood a real increase of vitamin D level in the young child formula that we did not observe in the control milk. And the most important consequence in this young child formula group is that you can see that we totally abolish the deficiency people, and we decrease by 50% vitamin D insufficiency in this control group in the young child formula, whereas in the control group and habitual diet, the level and the ratio of people which are deficient on vitamin D and insufficient in vitamin D did not change. However, in our study, we did not demonstrate any significant association between the level of vitamin D and the tibia SOS, suggesting that the vitamin D is not a key driver of the efficacy of our young child formula. Since there was a specific also whole blend, what we also test is that the efficacy of this whole blend to modify calcium absorption and magnesium absorption. So you can see on this graph that this whole blend significantly decreased the soap fatty acid soap in the after 6 months of intervention in the young child formula. But we did not observe any difference in calcium excretion, and we have the same result in magnesium excretion between the control milk and the young child formula. And there was no significant association between calcium excretion and TBSOS in our experiment. Therefore, we decide to investigate much more the impact of our symbiotic on the microbiome environment. So the first thing that we test is that do we have a real expansion of L. reuteri in the feces? And as you can appreciate here, in less than 3 months, we have a significant increase of L. reuteri expansion in the feces in the young child formula compared to control milk and habitual diet, which remain after 6 months of supplementation. But the result which were really more important for us is that we do not change only the expansion of L. reuteri, we change the global microenvironment of the microbiome, here particularly showcasing by this PCA a significant different microbiome diversity in the young child formula compared to control milk and habitual diet. And if you dig a bit more in the result, you can see that actually you increase different bacteria, particularly B. breve, particularly also L. rhamnosus in our study. So it's nice to change the microbiome and the level of different bacteria through this intervention, but the most important thing is do we change actually the microbial metabolite, which are the key driver of the bone and muscle activity. So what we did is we perform a full metabolomic analysis, and we cross-check the association between the different bacteria, the different metabolite, and the health outcome. And you can see here through this different complex heat map. On the right, you have the different bacteria. On the bottom, you have the different metabolite. And at the middle, you have a clinical outcome. And what we demonstrate, actually, is that there is key microbial metabolite which are increased by the Young-Child formula, like, for example, lysine, histidine, pipicolinic acid, and different indole, which are increased by the experimental Young-Child formula compared to control milk. As you can see also on this histogram, the amplitude of the effect and the top 3 metabolites which are increased by this Young-Child formula. And these top 3 metabolites actually were significantly associated with the bone quality, as you can appreciate. We did exactly the same exercise with muscle. I'm not able right now to communicate around the microbial metabolite association to the muscle, but what I can tell you is not the same metabolite who are doing the job on the bone and the muscle. So I'm arriving at the conclusion on this study. So we clearly demonstrate for the first time the concept of a gut musculoskeletal axis is not only true in aging, but it's also true during early life, and that a Young-Child formula with a symbiotic of coarse and hereditary has a superiority compared to minimally fortified cold milk on bone and muscle in toddlers. That the symbiotic actually restores the vitamin D insufficiency. But vitamin D and all blend do not explain the superiority of the Young-Child formula on the bone quality and bone strength. And more importantly for us, that the Young-Child formula induced really a microbiome changes, particularly by promoting expansion of hereditary and bifidobacterium, as well as specific microbial metabolite production, which are particularly coming from the tryptophan pathway that may support bone and muscle strength. So the take-home message that I would like to give you today is that actually the gut musculoskeletal axis is really a new concept in early life, and due to that, it needs really much more new RCT to confirm the efficacy of a symbiotic. You can see on this graph that there is not only the short-chain fatty as a key metabolite in the gut musculoskeletal axis, and we demonstrated in our study that tryptophan is also key, indole is also key, and there is, as you can see, many other metabolites that need to be investigated in order to reach a health benefit. What I would like also to give you as a message is not only one probiotic which can be the magic bullet and do everything. You need to consider micro and macro nutrient environment in order to get an efficacy of a probiotic intervention. I would like to thank you for your attention.